All right, everybody, welcome to Math with Grace. Today we're going to be going through Algebra 2, Book 1, Lessons 11 through 15. Lesson 11 begins on page 37, and it's titled Compound Inequalities. It says here that a compound inequality consists of two inequalities joined by the word and or by the word or. The and compound is known as a conjunction. The or is known as a disjunction. The graph of a conjunction shows the values that satisfy the condition of both inequalities at the same time. So a conjunction looks like this, two spots connected in between, okay? The solution of a disjunction is a range of values that satisfies either the first or the second inequality. And disjunctions look like this. They have a gap in between, and they not usually always go opposite each other, okay? So there's a gap in a disjunction. In a conjunction, we're talking about they're connected, okay? Let's take a look at the bottom of this page here. They want us to solve and graph the solutions for the conjunctions, and they've written it in kind of an interesting way. This 5 is less than the quantity x over 2 plus 6, which is less than 9. So this is two pieces, okay, put together into one statement. So hence we have two less than symbols, right? It'd be like having two equal signs, which can't happen, but we can have two inequalities in a statement. Now, they've written this all as one, so we're just going to go ahead and solve it as one. They've rewritten the problem here. Remember, we want to get the x term by itself. 6 is being added, so we're going to do the opposite and subtract 6, but we need to make sure we subtract 6 from both of the inequalities. So we subtract 6 from 5 and get -1. We subtract the 6 from 9 and get 3. Now x is being divided by 2. We're going to do the opposite and multiply, but we need to make sure we multiply both by the 2. So -1 times 2 is -2. 3 times 2 is 6. So now we know that -2 is less than x, which is less than 6. So less than means open circle, right? So it's the -2 is where we're starting, and the 6 is where we are ending, or, those are our two numbers at play here. And x, when we write it like this, is in between. So we know we're going to be filling in the in between, right? We want to be, our number here needs to be greater than 2, but less than 6. Okay, and that's everything in between, not 2, but -2. Everything in between that -2 and the 6. All right, let's turn the page. Now, with that conjunction, we simplified it all at once, but when we simplify disjunctions, we have to simplify the two inequalities independently on their own. So here are the two that they've given us. The quantity -2x plus 1 is greater than 3, or, okay, 2x is greater than or equal to 5. So we need to solve each one independently. So here's what they've done here. They've subtracted this 1 from both sides and then divided by this -2. Now, when they divide by that -2, right, the sign has to change, has to turn around. We're talking about inequalities. And so now we have that x is less than -1. The other disjunction, the other part of this inequality, was 2x is greater than or equal to 5. Dividing both sides by 2, we get that x is greater than or equal to 5 over 2. Now, just like we solved them separately, we're graphing them separately, but we're graphing them on the same number line, but separately. So, I like the short and sweet version of the number line. So if I were graphing it, I would have my -1 here, right? X is less than -1. And x is greater than or equal to 5 over 2. Okay? Greater than or equal to tells us we're filling it in, and it has to be greater. Okay? So that's how I would graph it. Here is the fancy number line. Obviously, 5 over 2 is a fraction, so it's not going to be a whole number. But that looks fantastic. Okay? Continuing on to example 3. It says, solve and graph the solution for the conjunction 4x is less than or equal to 12, and 2x is greater than 2, okay? Now, because we still have the and, but we're going to solve them separately since they were given to us separately. Because in the last one, that quantity was compared to both sides. But in this case, we have a different quantity compared to this side than we have compared to this one. So we're going to solve these separately. 4x is less than or equal to 12. They just divided by 4 to get x is less than or equal to 3. 2x is greater than 2. Solving gives us x is greater than, okay, 1. They accidentally wrote an equal sign, but greater than 1. So now we are going to graph them. X is less than or equal to 3 is our solid line, and we know we're going to go this direction, right? X is greater than 1 is our open circle, and it's going this direction, so we just draw the line solid in between. And then they rewrote it like this, which you can do. If you don't rewrite it like this, it's not the end of the world, but you should get comfortable to seeing that and knowing that this is a conjunction. All right, example 4. It says compound inequalities are useful for specifying ranges and limits in life applications. So now here's a story problem that uses this. It says the following illustrates the range between freezing and boiling points of a certain mixture. Write a corresponding compound inequality to show the temperatures when the mixture is either frozen or neither, frozen nor boiling. So this is what they want us to show. We need to write this part now. So seeing that negative 35 degrees Fahrenheit is our lowest, okay, that's what we write here. X has to be greater than that, but X has to be less than 278 degrees Fahrenheit. Continuing that, up here at the top of the next page, it says the second graph illustrates the temperatures where the water glycol mixture is either freezing or boiling. So now we want, what is it if it is freezing or if it is boiling? Now, since these have a gap, right, in between, this is the or statement. If X is less than or equal to negative 35 degrees, or X has to be greater than or equal to 278 degrees. So there's our disjunction. Now these conjunctions and disjunctions form what we call truth tables. Truth tables can be used to evaluate whether a compound statement is true or false. A conjunction is a compound statement that is true when both simple statements are true. The symbol, I don't know, this A without a cross, which stands for and, okay? So P and Q is what they have here. Usually P is your hypothesis, Q is your conclusion, kind of like an if-then statement, okay? So if P, then Q, and here they have P and Q, okay? So P is just one statement, Q is the second statement, P and Q are the two statements together. Now, P and Q can only be true if both P is true and Q is true. Your first statement must be true. Your second statement must be true for the and statement to be true. Now, a disjunction, which is a compound or a statement, P, V, Q, right? So it's the opposite of the and. This is our or. Is true when either of the two statements are true, right? So if the first statement is true, your P or Q statement is true. If the second statement is true, then your P or Q is true because we want or, right? One or the other. So either one can be true for the entire statement to be true. So now let's look at what that actually means here in some problems. Let P equal X is less than 9 and Q be that X is greater than 4, and then complete this truth statement, okay? So here we have X is less than 9, X is greater than 4, and then they gave us three other numbers. 15. Is 15 less than 9? No, so it's false. Is 15 greater than 4? Yes, that is true. P and Q. So it has to be both of these things when we have an and statement. Since it isn't 15 doesn't fit both of these, then our and statement is false. Let's look at the next one. 5 is less than 9. True. 5 is greater than 4. That is true. So because they are both true, then our and statement becomes true. That solution is true for our two statements together. Therefore, it's true for our and statement. Okay? 3 is less than 9. True. 3 is not greater than 4. That is a false. So therefore, our P and Q, does it fit both? No. So it is a false for P and Q. All right? Let's turn the page. We have one more example here at the top of page 40. And it says, let P be x is less than -3 and Q be x is greater than 4, and complete this truth table for our OR statements. So -7 is less than -3. True. -7 is greater than 4. False. But because this is an OR statement, I only need one true here to make the whole statement true. So this statement is true. 5 is not less than -3. 5 is greater than 4. So because 1 is true, the entire OR statement is true. 3 is not less than -3. 3 is not greater than 4. Therefore, the statement is false because we didn't get a single true. All right? Let's take a look at some of these problems together. We're going to be solving and graphing each of these inequalities. All right, so we're doing Algebra 2, Book 1, Lesson 11, page 40. Number 1 reads, 4 is less than the quantity x plus 7, which is less than or equal to 7. We're going to solve this kind of at the same time. But remember, we have two inequalities that we're working with. So x we need by itself. 7 is being added to it. We're going to do the opposite and subtract 7 from each spot, right? Here they cancel. 4 minus 7 is a -3, which is less than x, which is less than or equal to 7 minus 7, or 0. So in this case, 0 is one of our numbers. Doesn't happen often, but it does happen. So I have my number line, because they want us to graph these, and I have my -3 and my 0. X has to be greater than -3, so open circle, but less than or equal to 0. And because it is a conjunction, we want everything in between. Now, the book draws their lines right on the number line. I like to draw it slightly above just because it makes it easier to see. If you're going to be drawing on the number line, make sure it's nice and dark so I know exactly where your lines are, okay? Number 2, -5 is greater than, really, the quantity x plus 5 divided by -2, which is greater than -15. They kind of manipulated the problem here, but let's just go ahead and solve it, right? So our x term is being divided by a -2, so we are going to do the opposite, and we're going to multiply everything by a -2. Now, we need to remember when we're multiplying by a negative, we need to change our signs around, both of them, okay? -2 times -5 is a +10, which is now less than x plus 5, which is now less than -2 times a -15, or 30. X is, or 5 is being added to x. We're going to do the opposite and subtract. So 10 minus 5 is 5, which is less than x, which is less than 30 minus 5, or 25. So here is our new statement, our simplified statement. I guess it's not new. It's the same as it was. It's just simplified. 5, 25. This is a conjunction or an and statement. Both of them are less than, and so it's going to look like that. Open circles, line in between. Let's look at number 3. X is less than 3, or x is greater than 11. So this one's pretty straightforward because we don't have any extra math to do. So we're just going to make up our number line real quick. X is less than 3. Remember, when we set it up with our variable on the left-hand side, the inequality actually shows us which way our arrow should go. and x is greater than 11. So again, our arrow should go that way. So that's what our disjunction looks like for number 3. Let's do a few more. All right, let's take a look at number 5 together, and then we can look at the book for the next group of problems. 5 reads, 5/3 is less than or equal to, I don't know when they choose to use parentheses and why they choose not to here, but the quantity x divided by 6 plus 1, which is less than 7/2. Now, a bunch of fractions here. We'll deal with those as they come. All right, I'm not going to go out of my way to clear up the fractions just yet. And here's why. Here's what I'll show you, right? So we're trying to get this term by itself to start. 1 is being added to that. We're going to do the opposite and subtract. But when we subtract our 1 here, when we come over here, I'm going to subtract my 1 in the form of 2/2, since the denominator here is a 2. And on this side, I'm going to subtract it in the form, I didn't really leave myself enough room, 3/3, right? Because this is that denominator. If I had made the 1 have a common denominator, that's what they would look like for each side. So I'm still subtracting 1 from each side. I've just made it their own, right? Little denominator thing. So 5/3 minus 3/3 gives me 2/3, which is less than or equal to x/6, which is less than 7/2 minus 2/2, which is 5/2, right? So that's why I didn't go first and make them all have the common denominator, because now x is being divided by 6. We're just going to multiply everything by 6. And so it really wasn't necessary to take the extra step of having them have a common denominator. All right, so we just subtracted our 1 in whatever form we needed it to be. So 3 goes into 3 once, 3 goes into 6 twice, 2 times 2 is 4, which is less than or equal to x, which is less than, 2 goes into 2 once, 6, 3 times 5 is 15. So we have 4 is less than or equal to x, which is less than 15. Our number line is going to look like this, ish. Like I said, you don't have to get too complicated. At our 4, it's going to be a solid dot. That is important. At our 15, it's an open circle, and we are taking everything in between. Okay? This is our and statement, our conjunction. All right, let's go back to the book for the next set of problems. 7 through 12, they want us to write conjunction or disjunction to identify the graph, and then write the inequality that goes with each graph. You can just put C or D. I don't need the whole word. There's not a lot of space here. So number 7, we know that they are going from one to the other, so we're going to call this a conjunction because that's what it is. My lowest number is 17. My highest number is 35. Okay? X is greater than or equal to that 17, but less than that 35. Okay? Open circle tells me it's just less than. Solid circle tells me it's greater than or equal to, because it needs to be to the left, right? And so there is our statement that matches that graph. Let's look at number 9. Number 9 is another conjunction, right? We've got the space in between. Here, our lowest number is -15, and our biggest number is 13. Here, x has to be less or greater than or equal to the 15, but less than the 13, right? We want it to fall in between. It's equal to the 15. It's less than the 13. So that is our statement for the graph. And number 11 is a disjunction because we have a gap in between, okay? So we have two parts. The first part is that x is less than or equal to -4, right? That's what this one is. It's a solid dot, so I know it's equal to, but also less than because the arrow is going to the left. And x is greater than or equal to -3. Again, solid dot, arrow pointing to the right, greater than or equal to. All right? A couple more that I want to do with you here is this truth table and then this story problem, and the rest then you can finish on your own. So it tells us to complete the truth table for the given values. We have our P is x is less than 17, our Q is x is greater than -3, and we have an OR statement here. Make sure you're recognizing that. It obviously makes or breaks this truth table. 12 is less than 17. True. 12 is greater than -3. True. Our statement then is true, right? For an or, we only need one of them to be true. We have both of them to be true, so it's true. -5 is less than 17. True. -5 is greater than -3. That is a false statement. Okay? Because it is false, our statement, though, is still true because we had one true, and this is an or. We only need one or the other. Okay? What about number 30? 30 is less than 17. False. 30 is greater than -3. True. Our statement, our truth, our or statement is true because one of them was true. All right? Let's look at number 16. Straight 30-weight motor oil has narrow operating range of 32 degrees Fahrenheit to 86 degrees Fahrenheit. Write a compound inequality that illustrates the range of temperatures that the oil can be used in. So a lot of these story problems, they try to throw in extra numbers, times, dates to confuse people. So we're looking for a range of temperatures. That's all we need. Our lowest is 32 degrees Fahrenheit. Our highest is 86 degrees Fahrenheit. Okay, they want the compound inequality that illustrates the range that it can be used, which is between these ranges. So we need it to be that x is greater than 32, but less than 86. Okay? And probably the equal sign. Let's throw the equal sign in because it says of 32 to 86, so those should be included. Okay, we don't want to miss that. This word to tells me it's these included in that range. All right, so 32 degrees Fahrenheit is less than or equal to x, which is less than or equal to 86 degrees Fahrenheit. All right, they just want you to write the compound inequality. You don't have to graph this one. And so that's all there is to it. Go ahead and finish the rest of these problems, and then I'll meet you for lesson 12. Lesson 12 begins on page 42, and it's titled Multiplying Polynomials. So when we're multiplying two monomials, right, we want to group their numerical and variable factors separately. Now, they've really broken this out, and it's quite impressive, but we don't need to go that far, I don't think. But we're definitely going to multiply coefficient by coefficient. 5 times 3 is 15. And then we're going to multiply the variables times the variables, right? Combining the ones that are like. Remember, when we're multiplying exponents, okay, so like squares, cubes, whatever, we actually add. When we're multiplying like bases with exponents, we add the exponents, okay? So a squared times a to the 1 power, technically, is a to the 2 plus 1, or a to the 3rd. B times b, each of them to the 1 power, is the same as b to the 1 plus 1, or b squared. And because we only have one c, we're not actually multiplying it by anything, and it can just sit right there, okay? So when we're multiplying exponents, bases with like exponents, then we add those exponents. Okay, what about if we're multiplying binomials? Well, when we multiply two binomials, we want to use the FOIL method. Hopefully that's review, but let's take a look at what the FOIL method stands for. Each letter means something. So the F stands for multiplying the first terms times each other. So 2x times x is 2x squared. The O represents the outer terms. So the 2x times the -4, which is -8x. The I is the inner terms. So the ones that are closest to each other. The 3 times x, which is 3x. And the L means the last term, so the last one from each set of parentheses. So 3 times -4, which is -12. We then combine our like terms, which are these x terms. My circle went a little wide. These x terms here. And we get 2x squared minus 5x minus 12, okay? Now, we have a couple of specialty patterns that come with binomials times binomials. The first is known as a sum and difference binomial. And what that means is that the variable and the constant are the same. The only difference is one is a sum or adding and one is a difference or subtracting, right? X plus 3 times x minus 3 is a sum and difference binomial. When we do these, all we have to do is multiply the first terms and multiply the last terms. We can forget about the oi and FOIL. We don't need those. We just need the full, okay? So when we multiply the first terms, we get x times x, or x squared. We multiply the last terms, 3 times negative 3 is negative 9, and that is our answer. Sum and difference binomials are super awesome, easy ones, okay? Piece of cake. Looking at the top of page 43, we have another sum and difference binomial, okay? 3x squared plus 5 times 3x squared minus 5. So again, we want the first and we want the last, and that's it. 3x squared times 3x squared is 9x to the fourth, right? X squared times x squared is the same as x to the 2 plus 2, or x to the fourth. 5 times negative 5 is a negative 25. This will always be a negative in between the two terms with a sum and difference binomial, all right? The second patterned one is here when we have, I don't want to cut out the words just yet, hold on. When we have a square of a binomial, we're squaring one binomial. And so to solve that one, we're going to square double square, okay? And here's what that means. We're going to take the first term and we're going to square it. So x squared is x squared, right? Then we're going to multiply these two terms together. So 7 times x is 7x. Then we double it. That's the double part. So 2 7x's is 14x. And then we square the last term, which is the 7. 7 squared is 49. So we square double square. Here's the breakdown of it right here. Square the first term, double the product of both terms. So you multiply these two terms together and then double it. And then you square the last term, the second term, okay? Square, double square. So let's take a look at example 6. 3x minus 2, the quantity squared. So 3x squared is 9x squared, right? 3 squared is 9, x squared is x squared. Negative 2 times 3x is a negative 6x. We double that negative 6x and we get a negative 12x. Then we take our 2, the sign doesn't matter because you're squaring it. So this term will always be positive, right? Negative 2 times negative 2 is positive 4. 2 times 2 is 4. So this term, this final constant will always be positive. All right. So those are the squaring of the binomials. Now, multiplying polynomials of 2 or more terms means we just have to multiply every term of the first polynomial by every term of the second. And in this case, they have a binomial times a trinomial. There's really no secret here. They've broken it into 2 parts, which is probably the easiest. I don't know why they did it like this, but whatever. And then you're going to distribute through to each part and then combine your like terms. And so here's when we have lots of different terms, here's how I like to mark them. So I combine them. My terms to the third power, I'm going to underline. Terms squared, I'm going to overline. I'll put the single terms in a box. Here's an overline one. Here's a box, and I always circle my constants. This way I don't miss anything when I'm adding my like terms, right? Or I don't add one twice because I accidentally use it in an x squared and an x. This way I know exactly what I need to add. All the things underlined, add together. There's only one. All the things overlined, add together. So that gives me my 19x squared. The things in boxes get added together, and then my constant, if there was more than one, they would get added together. There usually isn't. Okay? Let's turn the page. Now, the top of page 44 gives you another way to multiply polynomials. I don't see many people using this method, but feel free to do that if you're more comfortable with it, and it's the vertical method. They put the polynomial or the trinomial at top and the binomial on the bottom and set it up just like a long multiplication problem. So that's how you solve them as well. 1 times -1 is -1. 1 times 2x is 2x. 1 times 3x squared is 3x squared. You would cross this out, right? Make a 0. They didn't do that part, but just that's how you would do it in regular multiplication, right? 3x times a -1 is -3x. 3x times 2x is 6x squared. And 3x times 3x squared is 9x to the third. And then you just, add moving down. -1 plus 0 is -1. 2x minus 3x is a -x. 3x squared plus 6x squared is 9x squared. And then there's nothing to add here, so it just drops down. Okay, so that's the vertical method. Feel free to use it if you like. If that seems to work better for you, then you do that. Now, division. It says division is the counterpart or the opposite of multiplication, right? To divide, the terms are broken down into their factors, which are then canceled. Now, this is pretty intense breaking down of factors. We usually simplify in class a little bit less space-wise, I guess. I don't know. 27, let's see, this is a q, I think. Q squared r to the third s over 9r squared s. Okay, so how we would normally do it, do 9 and 27 have a factor in common? They do. It is 9. There is 1 9 and 9 and 3 9s in 27, right? There's only one q term, so that's not going to matter. Now, when we cancel these, right here is what they did. They have the 3 r's here and the 2 here. Each one of these r over r makes a 1, right? Any number over itself equals 1. So that's how they get canceled out. But we can also think of it like this. When a variable crosses this line, this division line, it changes the sign of its exponent. So to get them to be both on the same side of the line, we would bring the smaller one towards the bigger one. Okay, in this case, the r squared would need to cross the line, and it becomes r to the 3 minus 2, right? It crosses the line, and this changes this sign to a -2. And when we have r to the 3 minus 2, it leaves this 1r left. So this is going to be gone. We're going to have 1r left. S over s is 1. So these cancel each other out. So this can start to get kind of messy. I like to go back through and circle what I have left. In my denominator, I only have a 1 left, so I don't need to write the denominator. Now, if we ever happen to have only a 1 left in the numerator, we definitely need to write that 1 in the numerator, right? But because it's in the denominator and it's just a 1, we can dismiss it. And so our answer ends up being 3q squared r. Okay? Now, if this way was easier for you to see, right, these 3's canceled here, then please do it this way. This is how I cancel. Usually that's how I'll be doing it in class. All right? Now, dividing polynomials by a monomial is a little bit different, right? And so we have to write the division problem in a fractional form, distributing the divisor to each term. So when we have the quantity 4x to the fourth minus 5x cubed y plus 6y divided by 2y squared, we're going to divide each term by that 2y squared. So we would set it up like this, and then we would simplify it the same way we did here or here, whichever way that you like to do it best, okay? So then we would simplify each one, which they haven't done yet. Okay, so this y is kind of weird. It should be on the line. It's not 5x to the 30y power. This y should be down on the line. But they're going to cancel it out, each one separately. So here, 2 goes into 2 one time, 2 goes into 4 twice. Okay, so we're left with, and our variables aren't the same, so they don't cancel at all. So we're left with 2x to the fourth over y squared. And then we have minus, we have only one y here, so it's going to cross the line and change its sign. So now we have y to the 2 minus 1, or there's only one y left. So the y is in the denominator. The 5 and the 2 have no factors in common, and there's nothing to cancel with the x, so that's that term, okay? And then we have 6y over 2y squared. Again, the y squared is larger than the y, so this y is going to come down. It crosses the line and changes its sign. So now I have y to the 2 minus 1, or just plain y. And then there's 1, 2, and 2, and 3 2's and 6. And so this one ends up being 3 over y. Okay? So that is how we simplify there. Now again, you could write it out each one like this and then cancel and see what's left. That works perfectly fine as well. Okay? Let's do some of these problems together. Okay, so we're in Algebra 2, Book 1, Lesson 12, page 45, and number 1. And these say multiply in whatever method you prefer. So we are multiplying 2x squared y times 4y to the third. Okay, so coefficient by coefficient tells me this is going to be an 8. 2 times 4 is 8. My x squared doesn't get multiplied by anything, so it just stays the same. But then I have y times y to the third, which is the same as y to the 1 plus 3, or y to the 4th power. Okay? For number 2, I have a lot of terms being multiplied by each other. I have a 7 and a 3 and a 2 as my coefficient, so 7 times 3 is 21, times 2 is 42. Then I have a squared, doesn't get multiplied by any other a's, so it's just there. Then I have a b times b squared, or b to the 1 plus 2, so b to the 3rd power. And then I have c times c squared, or c to the 1 plus 2, which is c to the 3rd power. Okay? So that's that one. Going on to number 4, we actually have our first sum and difference binomial. 2x minus 1 times 2x plus 1. Sum and difference. So remember, when we're doing a sum and difference, we only want the f and the l. So 2x times 2x is 4x squared. Negative 1 times 1 is a negative 1. Let's look at a few more. For number 7, we have the quantity x minus 3 times the quantity 2x squared minus x plus 4. Now, I'm going to just break this apart. So it's going to be x times 2x squared minus x plus 4 minus 3 times 2x squared minus x plus 4. And then we're going to distribute each one of these. Oh, that one went a little far. Don't forget this negative sign that belongs to this 3, okay? Let's do this one first. X times 2x is 2x to the 3rd. X times a negative x is a negative, or x squared. And x times 4 is a 4x. Negative 3 times 2x squared is a negative 6x squared. Negative 3 times a negative x is a positive 3x. And negative 3 times 4 is a negative 12. I'm going to mark my terms. So there's a x to the 3rd, x squared. There's just an x squared, an x, and a constant. Now I know what to combine. So I have 2x to the 3rd. Then I have negative x squared minus 6x squared. So I have a negative 7x squared altogether. 4x plus 3x is a positive 7x, and a minus 12. And there is our multiplied polynomial. Looking at number 9, it's the same process, but a much larger problem, right? So again, I'm going to rewrite it because there's a lot going on. 2x times x squared plus xy minus 3y squared plus 1 plus 2 times x squared plus xy minus 3y squared plus 1. Distributing the first one, 2x times x squared is 2x to the 3rd power. X squared times xy is 2x squared y. 2x times a negative 3y squared gives me a negative 6xy squared. 2x times 1 is a 2x. Okay, that's the first part. 4 terms here, 4 terms here. Okay. 2 times x squared gives me a 2x squared. 2 times xy gives me a 2xy. 2 times a negative 3y squared gives me a negative 6y squared. And 2 times 1 gives me that 2. All right. There are a lot of terms going on here, so we need to do some careful marking off. I'm going to still start with my underlining. Now I have an x squared y. I'm going to overline that. And remember that this operation term belongs to this term, right? The plus sign, because here I have a negative, right? Belongs to that. I am going to make a swoop under this xy squared. Then I have a regular 2x, which is what I normally put in a box. And then I have an x squared, which is what I would normally underline, but I already did that. So I'm going to just like make a swoop over it. And then I have an xy. I don't think I have any other xy so far. So I guess I can make this a squiggly. Wow, these all look different, huh? And if I do a squiggly over my y squared in a circle, every single term is different. There isn't a single term here that can be combined. So even though I marked up, I'm not going to rewrite this answer. Even though I marked it up, that is just the answer. Every single term is different. Nothing can be combined here. It's a big answer. All right, let's take a look at a few more problems. Okay, so the last two we're going to look at are division problems. We have 4x to the third y minus 5xy squared divided by 2y. So I'm just going to go ahead and divide here by my 2y. And now I'll take each term separately. Y over y, I already know is a 1, right? So I can cancel those out. 2 goes into 2 one time, and 2 goes into 4 twice. So I have a 1 is all that's left in my denominator, so I don't need to write it. But what I have in my numerator is 2x to the third. Okay, minus something, right? Here I have a 2 over a 5, or 5 over a 2, sorry. They don't combine in any way. The y's are the only thing that I can simplify. I have a 1y in the denominator, but 2 in the numerator. So this is going to come up, cross the line, and change its sign. So I have y to the 2 minus 1, or just 1y now in the numerator. So my 2x to the third is going to be minus 5xy over 2. Okay? You do not need to have these have a common denominator and actually put them together. This is a perfectly good answer. All right. Let's look at number 11. We've got the quantity 3ab plus 2a squared minus ab squared divided by a squared b. Okay, so a squared b, a squared b, a squared b. Okay. We've just rewritten it, dividing each term by the a squared b. I have no constants to cancel out here. My b's, b over b, is definitely going to cancel. And then I have these a's to deal with. Well, this a is just to a 1 power, and this one is to a 2 power. So the smaller one's going to come down. It crosses the line and changes its sign to a to the 2 minus 1. So we have 3 over a is all that's left. All right, 2 minus 1 is 1. And there's no longer an a in the numerator because it moved out, crossed that line, and changed its sign. Okay, so 3 over a plus 2a squared divided by a squared b. Well, a squared over a squared is a 1. So those can cancel, but nothing else can. So I have 2 over b is what's left. Minus, I have ab squared divided by a squared b. So this a is going to come down and cross the line and change its sign. This b is going to move up and cross the line and change its sign. So my numerator is going to be b to the 2 minus 1, and my denominator is a to the 2 minus 1, which is both 1s. So I'm going to have b over a. And that is my final answer. Okay? b over a. Remember, they crossed the line and changed their sign. You could have also written it if this is the way you're doing your problems, right? It's ABB over AAB. So these cancel, and I'm left with b over a. Same process, right? It just takes a little bit longer to write that all out. Okay? That's it for the problems we're going to do together with this lesson. Go ahead and finish lesson 12, and then I will meet you for lesson 13. Lesson 13 begins on page 47, and it's all about the slope formula. It says an important characteristic of a graphed line is its slope or steepness. One of the other books before this version called it slantiness. But the steepness of the line, right? And the slope is represented as the vertical change, or the change in y, over the horizontal change, or the change in x. And we call that the rise over the run. And the formula to determine the slope of a line is listed here. M, that letter represents slope, is equal to y sub 2 minus y sub 1 over x sub 2 over x sub 1. Now, when you get your pairs, here are the points that they're using for this example. You can label them. They've labeled them here, but I usually just write it over, right? X sub 1, y sub 1, x sub 2, y sub 2. I do that so that we don't get confused and accidentally write 5 minus 3, right? 2 minus 1. We don't want to make that mistake. We need to have our x's and our y's together, and we need to put the same one first each time. Now, you could have labeled this point as your 2's and this point as your point 1. It really does, that part doesn't matter as long as you keep them straight when you put them here. Okay, so putting the numbers into the formula correctly, we have our y sub 2, which is 2, minus, now this minus sign is part of the formula, but we have to remember that sometimes the number itself has a minus sign. So it's 2 minus this minus 3. And can we have a minus in math? No. So it becomes a plus. And then we have the 5 minus 1. Okay? So 2 plus 3 is 5. 5 minus 1 is 4. We can't reduce that. You should not be writing these as proper fractions, right? We want the improper fraction. You do not need to change it to a mixed number. That actually kind of messes up what we're working with here. So we just want to leave these as improper fractions. Now, this box at the bottom of the page tells us these different types of slopes that we can come in contact with. A positive slope is a line with a positive slope that rises from right to left. I'm going to kind of use this empty space over here. So a positive slope, here's my coordinate plane, goes like this, okay? If you were standing on it, you would be walking uphill, okay? That is a positive slope. A negative slope then would be the opposite, okay? It's a line that looks like this. If you were standing on the line, you would be walking downhill, right? That's a negative slope. A zero slope is a horizontal line with no inclination. So if this is my coordinate plane, here's my line. I'm standing on it, and it is just a flat horizontal line. That is zero slope. An undefined slope, or sometimes written as no slope, is a wall. So if this is my coordinate plane, here is my line. If there's no way for me to be standing on it, I am just falling to my death. Okay, right? I can't stand on this line because it has no slope. It is undefined. Parallel lines have the same slope, which makes sense, right? If they're running right next to each other and never ever touch forever, amen, they must have the same slope. Perpendicular lines have negative reciprocal slopes. So a perpendicular line would be two lines crossing at a 90-degree angle, and their slopes are negative reciprocals of each other. So this first line was a negative slope. This one would be the reciprocal in a positive slope. All right? So Important things to remember here. Let's go ahead and turn the page. The top of page 48 has us graphing by using the slope-intercept form. We used this form a bit last week to solve for 3 points on a line, but as it turns out, that form is enough for us to graph the whole equation just straight out, okay? So when we have an equation written in slope-intercept form, as the name tells us, we are given the slope, which is the m value, and the y-intercept, which is the b value. And then we can use those 2 points to graph our line. What we do is we graph our y-intercept first, and then we use our slope to go from there to find our second point. So skirting on down here, here's our example. Put the equation into slope-intercept form, negative 4x plus 3y equals negative 9. And so that's what they've done over here. They've added 4x to both sides, and then they divided by 3. And they ended up with y equals 4/3 x minus 3. Okay, there's our slope-intercept form. The minus 3 gives us our starting point on our y-axis, which is the vertical axis. Because it's a negative 3, we just count down, and this should have a negative sign in it right here. We count down 3, 1, 2, 3, and we put a negative sign, or we put a dot, sorry. We put a dot here. Then our slope is 4/3. It's a positive slope, so we know we're going to be walking uphill, and so we go up 4, 1, 2, 3, 4, and to the right 3, 1, 2, 3. Okay, and we would put a dot, which is what they did here, and then we would connect those dots, and that would be our line. You could continue on if your graph was a little bit bigger and go up 4 and over 3 more and put a second spot if you wanted. Now, if this was a negative 4/3, we would still be starting at this negative 3, except this time we would go down 4 and over to the right 3. Okay, we don't go down 4, back 3, because that would give us our positive slope still. We need to go down 4 to the right 3, always to the right. Okay, sometimes we go up, sometimes we go left, we always go to the right. All right, let's take a look at some of these problems together. So we're in Algebra 2, Book 1, Lesson 13, page 48. For these first 2 problems, they want us to solve for the slope. Now remember, the slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So marking my points, I'm going to have x1, y1, x2, y2. Okay, now I'm just going to put them into my formula. M is equal to 5 minus 3 over 4 minus 2. Remember, this negative is part of the formula. This negative belongs to that 2. Okay. 5 minus 3 is 2. 4 minus 2, we can't do minus in math, so that becomes a plus. So 4 plus 2 gives me 6. 2/6 can be reduced, so we need to do that. It has 2 in common. 2 goes into 2 once. It goes into 6 3 times. Our slope is 1/3. Looking at number 2, we have the points 0, 3 and the point 2, negative 4. X sub 1, y sub 1, x sub 2, y sub 2. And let's put it into our formula. The slope is going to be equal to y sub 2, which is negative 4, minus y sub 1, which is 3, over x sub 2 minus x sub 1, or 2 minus 0. Negative 4 minus 3 is a negative 7. 2 minus 0 is 2. Again, do not change this into a mixed number. Negative 7 halves is what we need because it gives us our rise over our run. Okay, if you change it to a mixed number, it becomes too complicated to graph properly. So we're just going to leave it like that. Now, for number 4 and 5, they want us to actually graph these equations. So we have y equals 5x minus 2. Remember, this is our slope-intercept form, and the 5x tells me I'm going to need to move at least 5 points, so we'll make our graph a little bit big. Okay. We start at our intercept. at -2. It's the y-axis. We want -2, and we're going to put a dot. Our slope is equal to 5 over 1. Remember, we want rise over run. So it's a fraction is really what we're looking for. Because it's a whole number, we just put it over 1. That tells me it's positive, so I'm going to be walking uphill. So I need to go up 5. 1, 2, 3, 4, 5, and over 1 place. I'm going to grab my straight edge and draw my line. Okay, so that's what that looks like. The larger this whole number slope, the steeper the line. The smaller it is fraction-wise or whatever, the more flat it becomes. Okay, looking at number 5. Y equals -x minus 1. Okay, getting my graph set up here. This one's pretty small. We don't need a whole big space. I'm starting at my y-intercept, which is this -1. So I'm going to go down 1 from my origin and put a dot. My slope here is negative, and it is equal to a -1 over 1, right? There is an imaginary 1, an invisible 1 here. So my slope is a -1 over 1. Negative tells me I'm going to go down 1 to the right 1. And I'll do 2 points since those are pretty close together. From there, I go down 1 to the right 1 again. Once that's done, I can connect my line or my dots and create my line. Okay. So this one has a negative slope. I'm walking downhill. Okay. Let's take a look at another one. Now, number 6 is written in standard form, 2x plus 5y equals 10. So we need to change it over to slope point form, or sorry, slope intercept form, so that we can solve these. So to do that, we want our y by itself. 2x is being added, so we're going to do the opposite and subtract it from both sides. So I'm left with 5y is equal to -2x plus 10. 5 is being multiplied by y, so we're going to do the opposite and divide each term, right? Now, y is going to be equal to -2/5 x. I'm just going to set the x on the outside. I can do that because it's in the numerator. It's the only time you can. Plus 2, right? 10 over 5 can be reduced to 2. So, setting up my graph here. Plus 2 is my starting point. So I'm going to start at my origin and go up 2 and put a dot. My slope is negative, so I'm going to be walking downhill. And I'm going to go down 2 over 5, to the right 5. So I'm down 2, 1, 2, 3, 4, 5 to the right. Those are my points. That is my point. Here's my ruler and my straight edge. And there is my line. Okay, please, when you're doing your work on your quizzes and your tests, if you're using graph paper, which I suggest, include it when you turn your tests in, please, so that I can see your work. Here's my line. If I was standing on top, I'd be walking downhill because it's negative. Good job. Okay, go ahead and finish the rest of lesson 13, and I will meet you back here for lesson 14. Lesson 14 begins on page 50, and it's writing linear equations. So from the last lesson, we were graphing them. Now we're going to be writing what the equation is, probably from a graph or a group of points. So knowing the slope of a line and its y-intercept gives enough information to write an equation for the line, the opposite basically of what we were just doing. This is the line in question. They want us to write the equation for this graphed line. Well, looking here, we already know what the y-intercept is. It's 1, 2, 3, a positive 3. So right off the bat, we know what our y-intercept is. From there, we can get our slope to see how far we have to go to get to the next point that was given. We can see that our slope is downhill, so we know it's going to be negative. And we go -2, so we went down 2 from our starting point, and then we went over 4. That can be reduced to a -1/2, And then we simply write that in, the slope and our intercept, into the formula. When we're writing these, the y and the x do not change. They just stay where they go. So y equals negative 1/2 x plus 3 is the equation for this line. Okay? Another way, another form we can use, that was the slope-intercept form, right? But another form is the slope-point form. They write point-slope. I'm used to saying slope-point. I'll probably say slope point. But what they got here is a bit of an error. I believe that was an equal sign, that y equals y to the 1, and that can't be because we already have an equal here. So it's supposed to be a negative. Y minus y sub 1 is equal to m, being the slope, times the quantity x minus x sub 1. And just like the y and the x in this formula, or in this form, don't change, they don't change here either. The only ones that do are the y sub 1 and the x sub 1. So if we know the slope and 1 point, we can write the equation of this line. Hence the term slope point formula. We know the slope, we know 1 point, we can use this formula to solve for the equation of the line. So let's look at example 2 on how we do that exactly. It says, write an equation for a line passing through the point 2, negative 2 with a slope of 3. Well, right away, we know that m is 3, and then we put in the points here for the x sub 1 and the y sub 1. So my y sub 1 was negative 2. My x sub 1 was a positive 2, but this negative is part of the formula, just like this negative is part of the formula. Now, y minus minus 2, we can't do that, so that becomes a plus. And then here we have to distribute our 3, okay? So we get 3x minus 6. And then we simply have to subtract this 2 from both sides, and we get y equals 3x minus 8. And that is the formula. We don't even have a picture of the line, but that is the formula of the line that passes through this point with this slope. All right? Let's take a look at page 51. At the top of page 51, it says, writing a linear equation from 2 points on the line. So, kind of like they did here, they're giving us 2 points, just without a drawing. Write an equation of the line passing through the points negative 1, 3, and 4, negative 5. First thing they did was use the slope formula to figure out that the slope was a negative 8 over 5. And then what they did was they substituted that into the slope-intercept equation and used one of the points, they used this point, negative 1, 3, to solve for the b, which is where it intercepts the y-axis, right? And then they were able to write their formula. Now, this first part, absolutely, have to solve for the slope. The second part, I would not necessarily do this way. I would have used the slope point form, and it would have saved us a step at least, because we wouldn't have had to solve for b by itself. So using the slope point form here, it would be y minus, and we can use the exact same points that they did. So let's just use the same points that they used, because they used the point negative 1, 3. So y minus 3 would be equal to my slope, which is negative 8 over 5, times the quantity x minus 1, right? Can I have a minus 1 in math? No, so it becomes a plus. So I have y minus 3 is equal to negative 8/5 x, we're just distributing this through, minus 8/5, and maybe that's why they didn't want to do it that way, but you're getting a fraction anyway, so one way or the other, it doesn't matter. But I need to add this 3 to both sides. But instead of adding just a 3 here, I'm going to go ahead and change it to have the proper denominator. So this is going to be 3 in the form of 15/5, right? 15/5 is the same as 3, and I'm adding. So y is equal to negative 8/5 x. Negative 8/5 plus 15/5 is a positive 7/5. So I feel like it's at least one step quicker to use this point slope form. I mean, That's what we're given. We're given 2 points. We solve for the slope, which we're going to have to do. And now we have the slope and a point. So I would use the slope point form. Now, obviously, you can use the slope intercept form because they did it. And you can solve that way. But personally, I would use this slope point form to solve. All right, let's take a look at some of these problems together. All right, we're in Algebra 2, Book 1, Lesson 14. We're on page 51. And they want us to use, for number 1 and 2, the point slope or the slope point formula to solve for the equation of these lines, okay? So remember, the y and the x do not change. We only change the sub ones, all right? So y minus 5, because that's my y here, is going to be equal to 1/2 times the quantity x minus 0. All right, well, minus 0 is really nothing, right? So it's just half x. So y minus 5 is equal to 1/2 x. I have to add this 5 to both sides. So I get that y is equal to 1/2 x plus 5. Oh my goodness. And that is the equation for my line that passes through this point with this slope. Okay, what about number 2? Well, same process, right? Y minus minus 1, because -1 is our point, but the negative sign is part of our formula, equals 3/2 times the quantity x minus 0. Again, with these minus zeros, y minus minus 1, no minus minus in math, so it becomes a plus. So I've got y plus 1 is equal to 3/2x. I'm going to subtract 1 from both sides. And I get that y is equal to 3/2x minus 1. That is the equation of the line passing through this point with this slope. All right, let's do a few more. All right, for problem 4 and 5, they've given us 2 sets of ordered pairs, and they want us to find the equation that goes through the line through those 2 points. For this, we need to make sure we know the slope, and that is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so looking at number 4, we're going to solve for the slope first. X sub 1, y sub 1, x sub 2, y sub 2. So I've got 5 minus 2 over 7 minus 3, or 3/4. That's my slope, okay? Step 1 done. I am going to use the slope point formula or form to solve for the rest. The book gave the example with the slope intercept, but that's what I'm going to do. So I have y minus, now the question is here, which point do I want to use? It really doesn't matter. You could use either point. I'm going to use the 3, 2 because the numbers are smaller. So it's going to be y minus 2 is equal to my slope, which is 3/4. This is times the quantity x minus 3. Okay, this is going to be distributed. So I have y minus 2 equals 3/4x minus 9/4. Okay, 2 is being subtracted from y. I'm going to do the opposite and add, but when I add 2, I'm going to do it with a denominator of 4, so that's 8/4, okay, that I'm adding here, because 8 divided by 4 is 2, right? That gets me back to 2. I just changed the form. I didn't change the value. Y is equal to 3/4x. Negative 9/4 plus 8/4 gives me a negative 1/4. Okay, that is the formula for the line that goes through these 2 points. See, it doesn't always, these points look great, doesn't always work out to be a clean formula. Okay, let's look at number 5. Same process. First thing we're going to do is solve for the slope. I have my x1, y1, x2, y2. So I have 5 minus 2 over 0 minus minus 4. Okay, remember the negative here is part of the formula. This negative is part of that number. 5 minus 2 is 3. 0 plus 4 is 4. So again, my slope is 3/4. Putting that into my slope point form, I have y minus, which one should we use? I'm going to use the first point here, only because I know I'm going to have to multiply this times this, and it will get rid of my fraction. So I'm going to use that one. So y minus 2 is equal to 3/4 times x minus 4. Okay, remember, this minus is part of the formula. This one belongs to that 4. Okay, can I have a minus in math though? No, so it becomes a plus. Y minus 2 is equal to 3/4 x, I'm just distributing, times plus 3/4 times 4. The 4's cancel, and it's just a 3. 2 is being subtracted from y. I'm going to do the opposite and add. Oh my goodness. Y equals 3/4 x plus 5. 3 plus 2 is 5. 3/4 x plus 5 is the formula of the line crossing through these 2 points. There it is. Okay? Let's do a couple more in the book. Taking a look at number 7 and 8, they want us to write an equation for the graphed lines. And the points that they've given us here, they're kind of hard to see for number 7, but it looks like they're these two. And number 8 are these two here. All right, so for this one specifically, we want to use the slope-intercept form. Now, here for number 7, it actually intercepts the y-axis at 0, so we're not even going to have a plus b, right? Remember, the slope-intercept form is y equals mx plus b, the plus b being where it crosses this line, right? Well, it's 0, so we're not even going to write that. So let's take a look at our slope between our points here. From this point, we went down, so it's going to be a negative slope when we went down 1, 2, 3. So I'm going to write a -3. And then we went to the right 1. There is actually a line here, even though it doesn't show it. 1, 2, 3. So we went over 3. Well, our slope then is -3/3, which is just a -1. So the equation for this line is y equals -x. You could write a -1x, but it's just a -x. There is no plus anything because we start at the origin. All right, it's negative because we're walking downhill. Good job. Number 8, we're starting out here. So our plus b, right, whatever this is going to be plus, well, not really because it's a negative, plus a negative number, but I don't like to write plus a negative. But we are at a -2, so it's going to be -2. Now taking a look at our slope, if we were walking on this line, we'd be walking uphill. So it's a positive slope, and it goes up 1, 2 points. And how far does it go over? 1, 2, 3, 4, 5 points. So our slope, rise over run, is 2/5. So y is going to be equal to 2/5 x minus 2. That is the equation for this line. All right? Go ahead and finish the rest of lesson 14 on your own. Looking at lesson 15 here, looking ahead, it starts on page 53. These will be this year for extra credit. So if you choose to do lesson 15, please make sure you photocopy it and give me whatever scratch paper that you used with your name on the pages. And if I will grade it, if you get an A, it will be worth 10 points of extra credit. If you get a B, it will be worth 7 points of extra credit. And if you get a C, it will be worth 5 points of extra credit. Anything less than that, it won't be worth any points. But it's a good way to earn some extra credit if you feel like, I know it's a little early in the semester, so maybe you're thinking, nah, and you don't have to do it. Obviously, extra credit is just that, it's extra. But if you feel up to it, then that is what that would be worth for lesson 15. And then once you're done then with lessons 1 through 14, go ahead and take your test. If you have any questions, do not hesitate to contact me. Otherwise, until next time.